All right. Okay, so for so real quickly here, a little technical difficulty. We're all getting this figured out. So, hello everybody out there in Ethernet land. We're here, and as I was saying before we actually had the camera on, is that I'm trying to get you, to do a chapter a week, okay? Kind of at your own pace, but I can't put everything out there on Classroom all at the same time. It just would be kind of overwhelming, and I know that it's been kind of overwhelming for some of you so far. You just can't seem to figure out how to do this online or how to submit things online or whatever. So we're all working through this together and being patient with each other. But I'm going to talk with you just a little bit today, covering the material that's in 8.7, 8.8, and 8.9. Okay, basically it's covering circumference and also similar and congruent figures. All right, not going to go through all the lessons. You guys can read, you guys can figure this out. If you really pay attention to the lessons, the examples, and the teaching that goes along with that in the book. Okay, some of you have been better about that than others. But we're looking at, I also will have out there later in the week the Chapter 9 test. So if you're just cranking along and you feel like you're ready to take the Chapter 9 test by Sunday, it will be out there too. All right. I think we're going to stick with the format of having the test posted out there and then using a Google Forms to enter your answers. That seems to be about the best way we can do it right now. All right. So you always have to let me know if you're having some problems. It should be working just like you've done some things with Google Forms or Google Classroom with Miss Heather, and it should be working exactly the same way, regardless whether you're using a phone, tablet, whatever. Okay. So let's just talk about circumference again for a little bit, and with our live audience and also you guys out there. So circumference is, remember, that circumference is the distance around a circle. If you could take a very flexible, not these steel tape measures, but a cloth tape measure, and you could start at one point on the circle and fit that tape measure around the circle back to where you started, that distance there would be your circumference. Okay, it's like perimeter when you're talking about polygons. All right, but because you don't have sides and you can't measure it on a circle like you do on regular polygons. So the way that we found out that you can measure the circumference is to be looking at the actual formula for it is pi times the diameter. Okay, and if you remember, in pi we use the number 3.14. Okay, so 3.14 is what we always use for pi, and then your diameter, you should know, is the distance across a circle from one point on the circle to another point on the circle through your center point. Okay, you also think about that as the longest part or widest part of the circle. All right, so if you measure the diameter and you take that times 3.14, that will give you your circumference. okay? And just using this formula. And we've talked about with all your problems that you'll have in the book or things you'll run into in the real world, okay? Just use this formula. And substitute in, depending on the problem that you're working, substitute in the things you know into that formula, and then solve for the thing you don't know. You know pi is going to be 3.14. So either you know the circumference and you're trying to find the diameter, or you know the diameter and you're trying to find the circumference. Okay? So that's really, don't make it too hard. Don't make it harder than it is. Don't expect it to be something more than that and then get yourself all twisted up trying to figure out, what's the hard way to do this. Okay? It's just really that simple. All right? So that's on circumference. This afternoon when you get this video, and if you have some questions while you're working through it, you can always ask on Classroom, and when I see it, I can help you. Or some of your fellow students have been really good about answering each other's questions, so take advantage of that out there on Classroom. Okay? So let's talk about congruent and similar. Okay? Congruent is what it's talking about in 8.8. So if you're following along, and the guys here in class follow along, if you just flip over to where section 8.8 starts, okay? And it's talking about congruent. Now, congruent, if you remember, okay, or you look back here, congruent just means same. So if you remember, it's the same shape, it's the same size. Oh, Mr. Kent. Same shape, same size. All right? So if you have a triangle and it measures 6 on this side, and it measures 2 on this side, and it measures 4 on that side, then another triangle, now it doesn't matter, let's just look at it, if it's the same size and oriented the exact same way, it's going to look like that. But even if it was laying on its side, okay, or even if it was upside down, if you've got the one side that measures 2, another side that measures 4, another side that measures 6, okay, it is a congruent figure. All right? So just remember, it has to be the same size, same shape, okay? And so anything, whether it's a rectangle, parallelogram of any kind, it's a rhombus, whatever it is, if it is the exact same size, exact same shape, it's congruent. Okay? And then, the only thing then is if it's similar. Similar means you can think of it as mostly the same or almost the same. Okay? So here it's going to be the same shape, but it's going to be a different size. Okay? It's going to be the same shape, but it's going to be a different size. That's what we mean by similar. Okay? If something's identical, it's in every single way. There's not a single thing that's different about it. But if it's similar, then it's mostly the same, It's almost the same. There's something that's different. In geometry, the thing that's the same is the shape. And the thing that's different is the size. Okay? So when you get into that section, that 8.9, if you look at that for a minute, in section 8.9 on similar figures, it talks a lot about proportion. And so you can look back if you need to, you can look back in a previous part of the book, previous section of the book, I think it was in the last chapter, about proportions, ratios and proportions. Okay? And so it's just like when we were shrinking a photo or expanding a photo. It's going to be the same shape, but the measurement of the sides and all are going to be different. And all of the sides have to be in the, the same proportion. Okay? If you reduce one side by 2, all the other sides have to be reduced by 2. So think about that. That's where some of you had trouble before we had this extended break, that you were having trouble keeping track between congruent and similar. And you weren't always sure what to do with the similar. Just remember that, let's see, so this, we'll look at an example and then we'll turn you loose here. So if I had a rectangle and it measured 6 inches on the long side, and it measured 2 inches on the short side, all right? And I had another rectangle. Notice from this drawing, it's not just my inability to draw things, it is actually a different size. And if all I knew was that the long side was 3 inches, okay? Notice same shape, but a different size, so these are similar figures. And if it asked me what was the measure of that side, okay, it has to be in the same proportion. So here we have 6 inches compared to 3 inches. That's a ratio. Remember, ratio is something that can be expressed as a fraction. Okay? And then on the other side here, we have 2 inches on top on this one, x on this one. So there's your proportion. And then you just solve for proportion. You should remember how to do that. You can do cross multiplication. So you have 6x, 6 inches x, equals 6 inches the other way. So 6 equals 6. Okay? Or sorry, yep, 6 equals 6. So if I'm solving for x, I have to divide this side by 6. So I have to divide this side by 6. And that gives me x is equal to 6 divided by 6 is 1. And so that means that this side is 1. Okay? So these are similar figures, and they have to be proportional. So that's how you would do those types of problems. Okay? So hope that helps you, and we'll see you out here again tomorrow. So y'all take care, be safe, stay healthy, and get out and quit bugging me.